this is a very important theorem, okay? If f is differentiable, right, then at a, it is also continuous at a, and it's also very simple to prove it, right? Well, what we need to prove is that the limit when x goes to a of f is the limit is f of a, that means that f is continuous, right? Is, let's see, sorry, what we have to do is that if, wait a minute, let me, if f is differentiable at a, that means that the limit when x goes to a of fx minus fa divided by x minus a exists. Okay, let's call it f prime at a. This exists, and we need to imply, sorry, to prove that this implies that this limit exists and is equal to f of a, right? But this is equal to saying that this difference, right, is 0, right? Or well, it doesn't matter the absolute value or not, right? So let's see, what can we say about this difference? Well, the limit when x goes to a of f of x minus f of a, right? And then we're gonna multiply and divide by x minus a, right? So then we have the limit when x goes to a of f of x minus f of a divided by x minus a multiplied by x minus a. Now this thing exists, is the derivative, so we can say that this is the limit when x goes to a of x minus a, right? That multiplies the derivative. Now the derivative is finite, and this limit is 0, right? So 0 times something that's finite is going to be 0, which is what we wanted to prove. Okay? So it's a very important theorem, and a very important consequence of this is that functions that are discontinuous, okay, will not be differentiable at the discontinuities, right? But another way of saying this is that if f is differentiable at a, it is also continuous at a. The other implication is not true, okay? If f is continuous at a, it doesn't have to be differentiable at a. Okay, typical example for this is the absolute value. Okay, the absolute value is continuous in R, right? But it is not differentiable at 0, right? If we compute the limit when x goes to 0 from the right of this x minus 0, right? Well, from the right this is 1, right? Because this is x when x is positive. If you compute it from the left, when x is negative, the absolute value is minus x, so the limit of this is minus x divided by x minus 1, okay? This is not equal, so that means that the limit doesn't exist, okay? And so this is the absolute value function, right? This means that at this point the function is not differentiable. One way of saying this or seeing this graphically is when a function is not differentiable at a point, it's you can see a spike, okay, something like that, okay, point, okay, a kind of cusp in this function, right? And so yeah, there are some other functions that you can try and prove that they're not differentiable. For instance, f of x, x times the sine of 1 over x if x is different than 0, or 0 if x is equal to 0. Well, this function is continuous because you can compute the limit when x times the sine of 1 over x goes to 0, and it's 0, right? But now if we compute the limit when x goes to 0 of x times the sine of 1 over x minus 0 divided by x minus 0. This is equal to the limit when x goes to 0 of the sine of 1 over x, and we know that this is doesn't exist. Okay, if the limit doesn't exist, the function is not differentiable at that point. Okay, that's the end of this